Hey Math Kids, today we're going to talk about the line of best fit, and we're going to do it just by using our eyes. And so the process that we're going to go through, we're going to first calculate the mean of the x and the y values, and then we're going to mark the mean point, so an x comma y value using both of those means, and then we're going to draw a line through the mean point which fits the trend of the data. Okay. So we're given one example in this section. I'm going to write the data just real quick. So we have A, B, C, D, E, and F. And then we're given 50, 5, 25, 40. Feel free to fast forward the video to get to the point where I'm done writing this. Okay, so this is time in minutes. And then this is temperature in degrees Celsius. Okay, so it says on hot days, 6 cars were left in the sun in a car park. The length of time each car was left in the sun was recorded, as well as the temperature. Okay, so part A, we need to calculate the average of the x's and the average of the y's. So we're going to create that average point for our line of best fit. All right, so opening up my calculator. I'm going to just add my x's all together. And there's 1, 2, 3, 4, 5, 6. So if I divide that by 6, I end up with 30. So my x value is 30. And then I'll do the same thing with my y value. 47, 28, 36, 42, 34, and 41. Once again, divide that by 6, and the average temperature is 38 degrees Celsius. Okay, so we did part A. Now part B says draw a scatter diagram for the data. And so my x values go from 5 to 50, so I'm just going to go 10, 10, 20, 30, 40, 50. And my degrees Celsius go, I'll do 10s as well, 10, 20, 30, 40, 50. And then I just plot those points, so I go 50, 47, 28, 5, wait a second, I did that backwards. So I want to go 5, 28, 5, 28, 25, 36, 40, 42, and then 34, 1, 2, 3, about there, or no, 15, I keep doing it backwards, 15, 34, about there, and then 41, 45, it's pretty close to that one. Okay, now I'm going to plot this point, which is 30, 38, which is right there. Okay, I recommend doing it in a different color if you have access to that, or somehow marking it as your mean point or your average point. Okay, now Part C says locate the mean point on the scatter diagram, then draw a line of best fit through this point. All right, so I will use yellow, and we want to go through the red and kind of keep it, I don't know, something like that. Obviously, if you have paper in front of you and a straight edge, you're going to do much better at this than I am. Okay, it says predict the temperature of a car which has been left in the sun for 35 minutes. So this is 20, this is 30, this is 40. So 35 is going to be like right there. And at least based on my graph, your graph might look different. It's going to be 40 degrees Celsius. Okay. Let's see. Oh, that's what the book got too. So I guess my drawing is not as bad as I thought it was. Now, predict how long it would take for a car's temperature to reach 55 degrees Celsius. So 55 is going to be about here. I'm going to go all the way over here. I'm going to extend my line and go down here, and then I need to extend this. And I would guess about 70 minutes. Once again, this is a rough estimate. The book ended up getting 75, and so you can see that's within reason. And then F, comment on the reliability of your predictions. I've kind of been doing that throughout. Not super reliable, but within reason. I would trust these if the data wasn't super crucial that I was exact. If you need additional help, please come to Math Lab. Until then, calculator.